new chapter, momentum. So we look at momentum, right? Now, momentum is defined as the mass multiplied with the velocity. Okay, one more time. The linear momentum of an object of mass m moving with velocity v is the product of its mass and velocity. So momentum is defined as the product of the mass and velocity. Now, in order to show that it is a vector quantity, we put an arrow at the top there. So the arrow on top of the P here shows that P is a vector quantity. Momentum is a vector quantity. It has direction. And also there is an arrow on top of velocity. Now this is to indicate that velocity is a vector quantity. So finally the equation will be something like this. P equals to m times v.
Okay.
Both the P and the V, they are vector quantity. So that means the momentum can be positive or negative. The velocity can be positive or negative. How about the unit? Because it is mass times velocity, so the unit is kilogram meter per second. Kilogram meter per second. Okay. Now, this momentum is like our velocity. If the velocity can be resolved into its components, the velocity can be resolved into the vertical component and the horizontal component. This momentum, which is also a vector quantity, can also be resolved into two components. The horizontal component called px and the vertical component called py, where px is m times vx. So that means the mass times the horizontal component is the horizontal component of the momentum. Py equals to m times vy. So that means the vertical component of the momentum is actually the mass multiplied with the vertical component of the velocity. Now next we are going to derive a relationship between the kinetic energy and the momentum. The kinetic energy and the momentum. Okay, right. The first one, kinetic energy we know is given by the formula half mv squared. Half mv squared. But from this equation here, we know that V is P over M. So you see P equals to mv. You bring the M over to the other side. So the V is P over M. So we have here the V is P over M. This is from the definition of momentum. This is from the definition of momentum. Now we found out that V is actually the momentum divided by the mass. Using this relationship, we substitute into the kinetic energy. Using this relationship, we substitute into the V square here. So the kinetic energy is half m V square. This is V square. So it becomes P square over M square. P square over M square. The M can cancel off, one of the M can cancel off, and the kinetic energy is the momentum square divided by 2m divided by the mass of the object. Now we can use this relationship, okay, to explain
Okay.
momentum and the relationship between the momentum and the kinetic energy. Okay, so this is the relationship. So remember, kinetic energy is the momentum square divided by 2m. Okay, so we look at the next question here, quiz 6.1. You read these two masses.
The two masses M1 and M2 with M1 being smaller than M2 have equal kinetic energy. How do the magnitudes of the momenta compare?
We have two objects. One object is m1, the other object is m2.
Yep.
We know that m1 is less than m2. That means the first object is lighter than the second object. Okay, the first object is lighter than the second object. But they tell us both of them, they have equal kinetic energy. One lighter object, one heavier object. In order for both of them to have the same kinetic energy, the first object must be moving faster, a bit faster, so that it can match the heavier object here. Heavier object is moving slower, a bit slower only lah, so that both of them, although they possess different mass and different velocity, yet
Mm-hmm.
their kinetic energy is the same. Yet their kinetic energy is the same. So that is why they say equal kinetic energy. One lighter, one heavier. One is moving faster, the other one is moving slower, but they are controlled by their kinetic energy. They have equal kinetic energy. So knowing this, we want to compare their momentum. We want to compare the magnitude of their momentum, not the direction, not the plus and minus, right? We just want to find the size of the momentum. So the
Okay.
first answer is, oh, we cannot compare them because there is not enough information. The second answer says the momentum of the first object is less than the momentum of the second object. The third answer says, oh, both of them, they have the same momentum. And finally, the last answer is the momentum of the first object is bigger than the momentum of the second object. So which one of these statement is true? A, B, C, D. Which one is true? Okay. This one is quite difficult to see because the momentum is proportional to the mass and the velocity. But the kinetic energy is proportional to the mass and the square of the velocity. It's not the velocity, it's the square of the velocity. So it's quite difficult for us to imagine quanti how to say, to imagine how the quantity change with one another. So I have to resort to mathematical proof. Okay, so I'm going to do a mathematical proof on this. I start off with the two masses. M1 is less than M2. So I move the M1 over to the other side. M1 over M2, and the other side is the 1. The symbol is still the same. When I move this M1, M2 to the right hand side, we say that M1 over M2 must be greater than 1. M1 over M2 must be greater than 1. So you just stop here. Regarding the mass, we just stop here. Then we look at the kinetic energy. They say the kinetic energy is equal. It's equal, right? So when I equate the two kinetic energy, which comes from this formula here, P square over 2m. So the kinetic energy of the first object, P1 square over 2m1. The kinetic energy of the second object, P2 square over 2 M2. Since the question says these two kinetic energy, they are the same, so I equate the two of them. I equate to two of them. And after that, I cancel off the two. Cancel off the two. Then the M2, I move to this side to get M2 over M1. Then the P1, I move to the other side. The P1, I move to the other side. So as a result, I get M2 over M1 is P2 over P1 square. M2 over M1 is P2 over P1 square. So this is the relationship between them, between the M and the P. Okay, so this is the relationship. Now from what we have seen earlier, M2 over M1 is greater than 1. M2 over M1 is greater than 1. But this M2 over M1 is actually P2 over P1 square. So instead of writing M2 over M1, I write P2 over P1 square. They're actually the same. We have found out mathematically they are the same. So, okay. Then to get rid of the square here, I take square root. Square root of 1 is still 1. So we have P2 over P1 is greater than 1. And finally, we have P2 greater than P1. P2 greater than P1 means P1 is less than P2. So the answer is B. P1 is less than P2. So this is a mathematical proof, right? If you want to explain it qualitatively, quite difficult to explain qualitatively because one is linearly, one is linear, momentum is proportional linearly to the v, but the kinetic energy is v square. So it's quite difficult to relate them unless we do a mathematical proof, right? Any questions so far on this relationship?
No question, sir.
No. So this one, no choice. I cannot explain it qualitatively. I can only do it mathematically. Okay, next one. So after knowing that momentum is